make a simple example of a cantilever beam, as you see here, and it has a concentrated load at the end here, and the characteristics of the beam are the lengths L and the E and I. So as you know, in previous lectures or previous modules, the analytical solution for this beam can be expressed like this as a function of x3 and x2. And for example, if you put replace x equal to L, you will find the deformation of the beam's end, this point, which is P times L3 over 3EI. So to be to start with the ETABS, I need to assume some numeric values for my parameters. So here I assumed P equal to 200 kilonewton, L equal to 2 meter, and E equal to 20 gigapascal. And for the I have assumed that I have a concrete section with 30 centimeter by 50 centimeters height. So the I parameter will be 1 over 12 multiplied by 30 centimeter and 50 powered 3. So if I replace these parameters into this formula, I will come up with 8.5 millimeter for the deflection of this point of this cantilever beam. So I want to see how can I model this simple beam with ETABS, and if I get the same result from ETABS or not. So if you run the ETABS, this is the first page you will see, and you need to make a new model by pressing this button here, or just going to the file menu and choosing the new model. So for the new model, which is just the beginning of any kind of modeling, is this page, this window, which you can either use saved user default settings or use setting from a model file that you have previously created. Or today I'm gonna use built-in settings with choosing my unit system. I prefer to work with matrix SI system, and this is region for default materials. So there's quite a few countries you can choose. However, later you can just modify these. Don't worry about these parameters. The units system is important, but the rest can be changed. Steel section database comes from Europe, and for the steel design code, you can see there are quite a lot of design codes like AISC, which is American code, and Italian or New Zealand, and this is the Eurocode 3/2005 for the steel structures. And for the concrete design code, again, you will see quite a few design regulations here, and we go for Eurocode 2004. And if you press OK, you will be diverted to another window that still you need to choose some parameters here. This is for your grading system, so again you can change it later, but because my beam is 2 meter, I prefer to have 2 grid lines in each X and Y directions with 2 meter lengths. just to be simple. And here it says how many story do you want. So the ETABS is specifically designed as a software for structure analysis and design of buildings. So it inherently understands what is a story in a building. And this is a very good advantage for this software. So for this case, I just use one story and the height 2 meters. And here you can select from different kind of structural objects like steel deck or staggered truss, flat slab, waffle slab, etc. And today I'm gonna just use grids only. Just press OK, and we will have here our model, which is, as you see, which is a 1 story, 1 bay, and everything is 2 meters here, 2 meters, 2 meters by 2 meters. And there are 2 windows here that shows what your structure is, and there is another window here and a bar here and your menus here. Some of the menu items are here, as you see in this bar, so you can later use any of them quicker if you want. So the zoom tools are here. This is the pan if you want to just move, or if you want to just zoom out or zoom in. As you see here, I am in XY plane, and you see what is X, Y, Z. So I'm in a plan, and you can do and you can model your beam wherever you want, but just to be a little more physics based, I prefer to go to sorry, this is plan view, this is 3D, this is plan view, and this is elevation. I prefer to go to the elevation, let's say 1. It's in XZ plane, so it makes more sense if I put the force on our beam. So as you see, we don't have any element. These lines are just grids, like what you have in AutoCAD when you want to draw some maps, and you need to create your model as you wish. So I will go to create your model. Everything is in draw menu. As you see, you can draw different kind of objects. And today I want to draw a beam column brace object. And here you can draw a beam column brace in plan, elevation, or 3D. So I just use this one to draw a simple beam from this point. Just grab it and until this point, and double click, and it will make an object for you. Just to come out of this mode of drawing, you can press escape, or you can just click on this object selecting tool here. Otherwise you will keep drawing some other elements as well. So this is a simple beam here, and I need to first, let's say, define this point as a fixed support. So I just select this point, this node, and when you want to attribute some characteristics or attribution to something like point or element, everything is in the assign menu. So I just selected my node, and when I go to the assign menu, I can go to the joint and I can use restraints. This tool helps me to define a kind of fixed support in that point. So I go for making this point a fixed support. As you see, you can use a simple support, a roller support, a free support, or a fixed support. When you press this one, all of the kind of deformations that that point possibly can have will be ticked. So when you tick these all, it means that the point cannot move at all in any kind of deformation axis. This is the translation along X, Y, and Z axis, and these three are rotation about X, Y, and Z axis. So if I press OK, you will see this point is a kind of fixed support, and this point is free, but just I wanna use this point to deform just in a 2D plane for me. That's why I just grab this point as well, and see this is the X and Z axis. I also assign joint restraint for this point. This is free, okay? And this is fixed. Everything is fixed. I want this point to be free in the X direction, in the Y direction, and in the X direction and in the Z direction for translational deformation, and in the Y direction for the rotational deformation. So as you see, this point is not allowed to deform in the Y direction, and this should be like this because it's a 2D analysis. It cannot go through the Y axis, and also the rotation about X and Z axis are meaningless for this case. So I just restrain them just for simplicity to be in the 2D frame analysis. So the next thing I want to do is to define the characteristics for this beam, and that's how I just select this one, and I need to first go to the define menu. In define menu, I need to first define a material property because I want to use my module of elasticity. So you can use these that are already available. For example, this is the default steel section, and this is the default concrete section. And I'm gonna use concrete, but I prefer to add a new material model from Europe and from concrete. And it doesn't matter which standard you use and which grade you use, because I'm going to change it, because this grade is important when you want to design the beam. And today I'm not going to design it, I'm going to just analyze it. So this is name, just the name. I just use my concrete as a name, and this is a concrete material, isotropic, and the only thing is really important today for me is the module of elasticity here, which in my case is, as you see in the example, I assume is 20 gigapascal. So I just put, because this is megapascal, so I just put 20,000 megapascal, and the rest, I don't touch the rest of parameters. I just put 0 here because I don't want the weight of the element contribute to my analysis. I want my force only to be this P here. If I don't put that weight 0, the weight of the element also will contribute in my analysis. So I just put the weight per unit volume equal to 0. Just ignore the weight of the element. So as you see, now we have the material of my concrete that I've specifically defined for my example. And I go for the define section and I use section properties and frame sections. I want to define a new frame section for my case. So for this one, again, I prefer to add a new property. And I have here, as you see, quite a few shapes for my section. You can choose. I just go with concrete rectangular, and this is the concrete rectangular, and it shows this box that I will put the name as my section. Let's say whatever you want to use here, it's okay. And I want the depth equal to 50 centimeter or 500 millimeter, and the width equal to 30 centimeter or 300 millimeter. Don't worry about the reinforcements here, because those reinforcements are important when you want to design the structure. And today we are going to just go for the analysis, not the design. So only the name, you should put the name here and the dimensions here and the material here, because I defined my concrete previously just to be used here. So when you choose my concrete, it means that it's a section that the material is coming from the my concrete that I just defined previously, and the dimensions are here. So just click OK and you will have your my section as a frame section property data. So you can press OK, and please note that when you define something here, it doesn't automatically go to your beam. You need to assign it to your beam. So I just select my beam and go to the assign menu, frame section property, frame section property. Okay, I just wait here, just you see where I'm going to. So when I assign something to my frame section property, it goes there. So you see here is my section. Okay, I just selected my section and OK. So if I press OK, my section will be here. If you I just make a clear window here. If you're not sure if it goes through your section or not, just go to your beam and right click on it. When you right click on it, this window pops up and you can see the different assignments. Your assignment is my section here. Okay, so you're pretty sure that my section is what it should be as a property for your beam. So as you see, the beam is blinking here. It means that this window, which is open, is showing the properties for this beam or this one. So this is just in 3D and this is in 2D. Okay, I just cancel this box, and the last but not the least, I need to put the loading on my structure. So I just select this node, and again I go to the assign menu, These are for assigning characteristics, and these are for assigning loads. So I go to the joint loads and forces, because you can define ground displacement as ground settlement or changes in temperature. These are all kind of different sources for loading your structure. And here I want to just put a simple force at the end of the cantilever beam. So I use joint loads and the force. So here you are to put your force. My force is 200 kilonewton, and you see the dimension is kilonewton. So I just put it a little bit here. You need to put your force here vertically. So vertically means along the z-axis, which means this one. I put minus 200. It means that it will be from to the down direction, negative z. So I just put it as a minus 200 kilonewton along the z-axis and just press OK, and you will see your loading is here. And again, if you right click on your beam, you will see your load is not here. So I just, let's say I want to save my model, for example, as a test. This is the file that you will have on your desktop or wherever. And if you click on the point, on this point, and you go to the loads, you will see there is a force along the FZ. So this is the force, that the value is minus 200. So okay. Now I think I have modeled everything. If not, when we analyze, we will see some messages and error warnings to alert us what is any kind of problem in our modeling or loading or any other kinds of stuff. So here you can press this one and run your model, or even you can go to the analyze menu and run your analysis, or F5 here. Some of the important buttons are provided in this bar, so you can use them simply. This is a kind of lock here. When you're working with your model, you're changing something, this lock should be open. And when you analyze your structure, this the whole thing will be locked. It means that if you want to, after analysis, if you want to change something, you need to unlock your model. Otherwise, you cannot change anything. So I just go for analysis, and I press this one, and I'm waiting for the software to analyze my structure. You will see something here. It shows that what the software is doing, and you need to wait for a couple of seconds, and you will have an analysis message here. So there is a warning here for me that says the structure has no mass, no eigenmode can be found because there is a modal load case. So okay, this doesn't have anything to do with my problem. However, I will fix it later for you to see what is this coming from. So as you see, the deflection is here in 3D. I can have it in 2D as well. This is the icon for showing the deformed shape of the structure. However, you can find it in the display menu, deformed shape. So this shows, or pressing F6 button, and shows the deformed shape of your structure. So If you press to this window to show the deformation of the structure, you will see this is the deformation. And if you right click on your interested node that you want to check, you will see the numeric values. However, I don't see it because of the restrictions of my monitor, so I just close the second window to have just one window, and I just a little bit zoom out just to have enough space. And now I can see here that the UX is 0, it should be, UY is 0, it should be, and UZ is minus 8.9 millimeter. You can you can see these data intuitively here, or you can go to the display menu, and the last item here is show tables. You can get all the results as a table. So here, analysis results from joint output, displacement, joint displacement. I just tick this box. I don't want to make too many tables for myself now, but you can get any kind of input and output as a table here. So I just use the joint displacements here, and if I press OK, you will see in story 1 and in label 2 means that point or node, I will have UZ millimeter minus 8.9. So this is the deflection of the end of the cantilever beam, almost 9 millimeter, but in the analytical solution it was 8.5 millimeter. Although they are close to each other, this is 8.5 millimeter and this is 8.9 millimeter, but this difference comes from different sources. But the most important source of this difference is that when we work out with this kind of analytical solution, we are just considering the effect of bending moments, and we are neglecting the deformations due to shear forces. So one of the main important thing is this one. This 8.5 millimeter is only based on the bending moments, and but in ETABS, when you calculate the deflection, it is considering all kind of deformations, including the shear deformations. So this is one of the most important sources of the difference. We can further go and revise our analytical solution to consider the effect of shear forces and to see how these numbers will get closer to each other. And this is something as a next step in the following weeks. And here, what else to do is, if I want to change anything now here, as you see, if I select this one, for example, or go to assign, this is not active. These are not active because I've already analyzed my structure, and the analysis output is saved in the memory of the software, and this is locked here. See, I cannot change anything unless I just unlock my model. But if I unlock my model, the results of my analysis will be deleted. It's okay. But if I unlock it, it reminds me unlocking this model will delete analysis results. If I say okay, I can change anything I want, but I need to reanalysis my model. Otherwise, this is something important when the analysis time is too much. So if it takes a couple of hours for your model to be analyzed, so it's important that you double think if you want to unlock your model, because again, you need a couple of hours to analyze your structure. So another thing is that here is load cases, and I have dead load, live load, and modal load. And this modal load is here as a default, but it is useful when you wanna calculate the modal shapes or eigenvalues or natural frequency of your structure, which is not the case in this model. So I just delete it, and I will not get that warning that I got previous case. So if I OK and rerun my model reanalysis, I need to wait a couple of seconds because the model is simple, it's not very complicated. So as you see, I didn't get that warning, and again the deformation is 8.9 millimeter. And this is the first example for you to just get started with the ETABS. And I strongly encourage all of you just to go to the lab and try to do what I've done today, and further implement some modifications as you wish, and just to play a little bit with the software, with the ETABS, and to see what it has and what it has not. So I will try to post more videos about this software before we get actually to the lab. We will do some more advanced analysis stuff there, face to face in the lab later this semester. But before that, the aim of these kind of videos is that just you to get some preliminary experience with this software, so it helps us to better understand what capabilities this software has. And this is for today, and thank you for your attention, and have a nice day.